I'll start with a simple. Let there be a point charge Q. And here I'm going to keep a dipole. So let the dipole moment of this be P bar. So it is kept at a distance X. Usually the length of dipole will very much less than the X. This is a condition. Okay, now we have to calculate the force of interaction between this dipole and the point charge. So what is the method here? We can assume this dipole present in the field of point charge, or the point charge present in the field of dipole. What is the electric field strength due to the dipole on the axis? What is the electric field due to dipole on the axis? That should be equal to 2p by 4 pi epsilon naught x cube. Can you remember? The electric field on the axis of dipole should be 2p by 4 pi epsilon naught x cube. On the bisector, this 2 will not be there. Am I right? And then on the axis, in what direction the electric field strength will be? In the direction of dipole moment. Now, what is the force of interaction? Q into E dipole. So this will become 2pq, or say Q. Further, you can simplify this. Now, what is the assumption we made? We made assumption that the point charge present in the field of dipole. Can we do either way? I'll assume that dipole present in the field of point charge. Yes. So what you should do here? You should calculate the force acting on positive charge, force acting on negative charge. The resultant of that force should be the required answer. Okay, can you hear me? No? Voice, all of you, you are able to hear me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Check from your side. Okay, I'll decrease the fan speed. Can you hear me now clearly?
Yes, sir.
Yes, sir.
Okay, technical side from your side, please check Yochin. Maximum from my side, technically there won't be problem. Only if internet is now there, then there'll be trouble. Otherwise, any troubles, no, check from your side only, please. Okay, there's a method of finding the force of interaction. So we can also do either way. What is that? I'll assume the field strength due to this positive point charge. Here, how it will be towards right. So here, this positive charge will experience more force than negative charge. The reason, because field strength due to point charge at 1 will be more than 2. Let me write symbol 1, 2, due to point charge E equal to KQ by X1 square, E2 equal to KQ by X2 square, X1 less than X2. So E1 greater than E2. The positive point charge is what actually experience force towards right. The negative charge, the positive charge, repulsive force it will be. Negative charge will be attractive, since like F1 will be greater than F2. So on the dipole, the force will be acting towards right. Okay, there's a very fundamental problem. So that's why I'm trying to explain using both the methods. You can see clearly here now. So this will experience a force F1, this will be F2. Since F1 greater than F2, so net force on the dipole will be like this. Okay, will it be attractive or repulsive? That one will be repulsive in nature. Okay, so now the concept will extend to between two dipoles. Now, if there are two dipoles are there,